Hi, my name is Matthew McLaughlin. I'm here today to conduct a little physics experiment on behalf of my class run by Mr. Chan. So what I'm going to be talking about today is three different physics concepts. What's in play? Buoyancy, conduction of heat, and free fall. And we're going to see how all these different forces play into even a very simple experiment such as this, Physics is everywhere, and this little tiny experiment is about to prove it. But first, what objects do we have in play here? Okay, we got 2 glasses of water, about the same, water level roughly. Got it. 2 Alka-Seltzers, a ping pong ball, and a golf ball. And we have one surprise item, but I'll bring that into play later. Anyway, we are first going to talk about a little bit about buoyancy and about free fall. Now, if I dropped these 2 balls, my first question is, what would happen? Would the golf ball fall faster, or would the ping pong ball fall faster? Well, because you got to figure, this ball's a little bit heavier, so hey, maybe it picks up more speed. Or hey, this ball's lighter, so maybe it can cut through the air faster. Or will they just fall at the same time? I'll give you a second to think about that. Good. Okay, so, and the other concept we're going to be observing is a little bit about buoyancy. What's going to happen when they hit the water? Will the golf ball submerge? Will the ping pong submerge? Will they both stay afloat? Give you another second to think about that. Perfect. Okay, so now, no more funny business. Let's get right to the experiment. There's my camera here. Yeah, okay. Get you a good angle. Oh, yeah, had it, lost it. Yeah, cool. Okay. So you can see that they're at the same height. This is a fair test. I'm going to drop them at the exact same time on the count of 3. 1, 2, 3. Wow. So we got a couple things going on here. As you could first observe, you saw that both of them dropped and hit the water at just the same time. So that speaks to our first concept, free fall. Gravity is going to act on all the objects the same no matter what. Galileo states that objects fall about approximately 10 meters per second. But if you want to get more precise, 9.8 meters per second. So it doesn't matter if we have a bowling ball or a tennis ball and we drop them out of a plane, they're going to free fall at the same exact rate because they are, okay, that's supposed to happen, because gravity acts on both of them the same. And now, what's the other concept we got here? We can see that the golf ball has clearly sunk into the bottom and our ping pong ball has stayed afloat. Now, why is that? We get to know a little bit about buoyancy to understand. So buoyancy is the apparent loss of weight on an object when submerged. Now, let's break that sentence down a little bit. So think about if you've ever been in the water. Why is it that you could take a boulder in the water and it feels a little bit lighter when you try and lift it up, but then when you get that thing out of the water, you're like, whoa, this is heavy. What is that? Because when you put an object in water, water exerts an upward force on it, making it lighter. And whether that object is less dense than the water will determine if it will float. So now let's take the ping pong, for example. Very bouncy, it's got some air in it. Shows you my skills. It can float because the water is more dense than the ping pong ball. We come over to here to the golf ball. Golf ball is a little heavier, it's a little thicker, they want to put all that stuff in it so we'll get maximum distance. That's why this thing is going to sink. Now, I got another little kind of side note experiment. What would happen if I added 2 Alka-Seltzers to the water? It's going to release those bubbles and bring the carbon dioxide up. Would the old golf ball float? Let's take a look and find out. Oh, but first, take out your response card and write down what you think is going to happen. Perfect. Here we go. 1 and 2. So let those bubbles kind of sizzle up a little bit, and then we'll bring our golf ball into play. Okay. Yeah, look at those things go. They are sizzling up in a storm. Okay, who's ready? I'm ready. Boom. And apparently, I'm amazed that this golf ball has no... the bubbles don't seem to have any effect on the golf ball. Why is that? Is it because the golf ball is extremely dense, or is it because the Alka-Seltzer is not really putting enough bubbles? By the way, I don't think I'm going to drink that. I don't think I'm going to drink that because I don't think that would be a healthy decision. Anyway, we'll put that to the side for a second so we can get started on our next experiment. So the next thing we're going to be talking about is physics I don't think we've covered in the class yet, but a little bit about the conduction of heat and what kind of objects are good conductors of heat and what aren't so good conductors of heat. So the next thing I want to talk about a little bit is what would happen if I were to set this ping pong ball on fire and to dip it in the water. Now, would the water boil, or what would happen? Would the water transfer some of that heat energy from here, or would this light up a little more? Let's go ahead and find out. But first, let me give you a second to write down what you think is going to happen on your response cards. Perfect. So here we go. I got my lighter, and that was the mystery object for those of you cool cats who remembered. And we're gonna light the flame, and we're gonna see if the ping pong ball is a good conductor of heat, and if water is a conductor of heat. So ready? 3, 2, 1. Seems to be imploding. Whoa! Hello! That thing is hot, hot, hot. Oh, I can smell that pencil burning. Okay, the ping pong is in the water. It is burning. It is burning. The water seems to be sizzling. Oh, but what is this? The ping pong seems to be. Oh, the fire has extinguished, or the water has extinguished the fire from the ping pong ball. Wow, I got really excited right there. Can you believe that? And have you ever seen a ping pong ball lit on fire? I don't think so. So this, oh, it smells terrible in here. Where's the camera? Yes, that's what it looks like. And it does not smell good in here, boys. Let me tell you that right now. So let's talk a little bit about what was going on right there in terms of combustion, or conduction, excuse me. So water is clearly not a good conductor of heat. Now, if it were a good conductor of heat, say as something like metal, then perhaps we would have had a ping pong ball that was able to boil this water. But since water cannot conduct heat very well, it was unable to transfer the energy from the ping pong ball into the water. Now, that's an important thing to note. Does that mean that the energy just disappeared? No! Absolutely not. Conservation of energy. Energy cannot be lost or destroyed ever. So what happened to all that heat energy in the ping pong ball and everything? Did it just disappear? No. It got transferred, and now that probably weird smell is probably some of the energy from the ping pong ball that released, and I'm sure some of the energy, ionized this water. But that's chemistry, and we're going to keep it to physics today. Okay? Great. So, we've talked about a lot today, and I know it's a lot to take in at once, but, I hope you enjoyed this video, and I hope you were able to learn something today. And, it was really a pleasure working with you, and I hope that we will someday meet again.